Welcome to our last set of notes and videos in AP Physics B. In the last chapter we learned about the nature of the atom. We learned about the positively charged nucleus and the electrons orbiting around it. Now we're examining the nucleus and how it manifests itself into radioactive decay and nuclear reactions. By the 1930s, a basic model of the nucleus was set as we know it. We had electrons that were bound electrically to the positively charged nucleus. All nuclei consist of two particles. We have protons and neutrons, and collectively they are found in the nucleus, and they are hence called nucleons. Now, moving a little bit ahead into the notes, I'm just going to jump into the next page here. Let's talk about the atomic number, which is represented with Z. Z is the number of protons in the nucleus. This is what determines what element in the periodic table it represents. So for example, if we're looking at, let's say, sodium here, sodium 11, the 11 tells us how many protons there are, and is also telling us the atomic number. Since each proton has a charge of positive E, where E is the charge of an electron, and that's found over here in the previous page. If you've forgotten, here's the charge of a proton. It's the same as an electron, except the electron is negative E. And you'll also notice that the mass of a proton is very similar to the mass of a neutron, except it is slightly less heavier than the neutron. And it can be written in terms of these units, which we'll get into a little later on. But once again, going back to the proton, it has a charge of positive E. So when we have an atom that has, say, 11 protons, then that charge from those 11 protons would be basically Z, which is the number of protons, multiplied by the charge of the electron. So basically the charge of the electric charge of a nucleus is Z times E. Okay, now if an atom is neutral, that means there are the same amount of electrons as there are protons. All right? Also remember too that in that nucleus we have neutrons, and neutrons have no charge at all. Okay, now in that nucleus we have nucleons, right? Protons and neutrons. The total number of protons and neutrons represents the mass number. So this is the total number of nucleons. It is often convenient to represent the different nuclei that we have. Now, there are 270 that are stable, but there's roughly 4.5 times this amount that are unstable. And I'll talk about that in a minute here. Let's just talk about how we designate the nuclei. When you write down a nuclei, often textbooks will use this notation, where we have the element here, X, which is sodium here, Na. Then along here at the subscript, Z is the number of protons, which is the atomic number. And then the superscript, it represents the number of protons and neutrons, which is the mass number. So if we were to write sodium 23, we would write it as 23 as a superscript, 11 as a subscript, and then you have the element here. And you should be able to identify how many protons, electrons, neutrons, and so forth are in here. We have 11 protons, that's the mass, that's the atomic number. We have 23 nucleons, that's the mass number. If you subtract 23 minus 11, you'll have 12, which represents the number of neutrons. Remember that the mass number, A, represents the total amount of nucleons, which is Z plus N for neutrons. So if you were to solve for the number of neutrons, you'd have to take the mass number and subtract the atomic number from that. Okay, also you'll notice that you may have not known this, but it was once thought that all atoms of a given element were identical. But that's not true. We now know that there exist different isotopes. And you should know what an isotope is. An isotope is a nuclei, different nuclei that have the same amount of protons, so the same atomic number, right? But they have a different atomic mass number. So you have, here's two isotopes. Oxygen, both the same element here because they both have the same atomic number, but one has a mass number of 16 and the other one has a mass number of 17. So essentially what's happened is they have a different number of neutrons. Okay, this one has an extra neutron compared to this one. All right, there are also isotones and isobars. The main one you should know is what an isotope is. Now, the most common notation we use for nuclei are this way, but there are some other ways that people write it. They might write this as, just write the word sodium-23, or they'll write it as Na-23. And you may often see this too, just 23 and Na, because people will know that it's sodium, and you know the protons from that since you know the element. Right? Even in older textbooks you have a lot of different versions, but nowadays it's generally accepted that we use this kind of notation. Alright, I think you should go on to example 2. Also take a look at example 1, which follows this video too, and practice interpreting the symbols, so this nuclear notation that we use, so you can indicate the number of protons and neutrons, mass number, you know, all the things that are in this table. So go ahead and do that example.